Here we go. All right. So I painstakingly made this last night. I was here for quite a while. The main thing I made was this box over here. Okay. So the reason I made this box, and I think I'm just gonna delete my. No, I like it. I like knowing that we're live in a classroom. Did you watch your video yesterday? Oh, huh? Oh, okay. Because you're in there. All right. We had an intro from a student. Then we talked about that student later in the video. Anyway, so what I thought, okay, hey, maybe I'll do like, hey guys, step one, step two, this is what we should do. And I'm like, no, wait a minute. I'm just gonna draw this box or make this box over to the right. And this essentially is the steps. Maybe not necessarily in order A through F, but you have to do A through F first. All right. And then look at what I put for A. We usually list, hey, find the domain, but you can't find that first. You got to find out and determine do you have vertical asymptotes, which is related to the domain, or do I have a hole? So A through E all have to be done first, not necessarily in A through E order. Does that make sense? Okay, so and because I could find x-intercept. Well, actually, that's a lie. What you need to do first, step one, if I were going to give you steps on how to do this, is factor. You have to factor the denominator. So, I'm sorry, the numerator and denominator. I just like randomly said words, and I'm not covering factoring. If you don't know how to take out a GCF at this point, I can't help you. It's beyond the scope of me being able to help you at this point. We've been doing it forever. You're supposed to do it the last two classes, including Math 1. I'm sure Math 1 we did GCF factoring. I hope. I don't know what Math 1 is anymore, but anyway. And then Math 3ers for sure. All right, so now what do I do? First of all, do I have any holes? Do I have any holes? Yes or no? No. We have no equal numerator and denominator factor. So that's good. We don't have to do that. Okay, and then this is what I mean. We can do whatever we want now. We can do like, if you want to grab out highlighters, go for it. Again, we'll highlight this first one, but I want to highlight some different stuff on some other ones. So I may just highlight the components that we find on this one, and then for separate questions, some other stuff. Okay, so it's zeros of the numerator. And then, hey, what's y-intercept? And then again, I had people working right away, and then they forgot how to find y-intercept after 3 times of doing it. What do I plug in for x for a y-intercept? 0. And I hope you can see me, but I don't know if you can see the screen. This is what I do. 0 squared plus 0. Shh. What just happened? Over 0 minus 2. So what's 0 over negative 2? And I'm actually going to write that there. 0, comma, 0 over negative 2. What's 0 over negative 2? It's 0. And by the way, that's not a coincidence. An x-intercept 0, 0, so therefore it's also a y-intercept. That's not 2 different points. That's the same point. So here's how I find y-intercepts. Those x's turn all into 0 because I plugged in 0 for x, and I get 0 over negative 2, which is 0. I don't know what else to do, man. That's another basic concept. All right, next, that's vertical asymptote. Zeros of the denominator. So we have one at x equals 2. Now here's the real reason why I changed that to x minus 2 instead of that 4x, whatever, negative 4x. Now we can find that horizontal asymptote, and you don't even need that much space. To find a horizontal asymptote, go back to the original and synthetically what? Divide. And then guess what? That's 1x squared. That's 3x. What's missing? Even though I don't really need it, but I do want to write it. 0. The last term is 0, the missing constant. And the reason I do that is if we had to synthetically divide and we're missing the constant and I had to write a synthetic division answer completely, I have to incorporate that. All right, and then next, sorry, I didn't leave any space for the adding, but bring down to 1. 2 times 1 is 2. 2 plus 3 is 5. I think you could hold that in your head. 2 times 5 is 10. 10 plus 0 is 10. What do we do with the remainder? What did I tell you yesterday? You really don't need it. But if it was a synthetic division question, what's the answer completely? Then I would have to have 10 over x minus 2 as the final term. All right, so that's why I want you to understand this whole idea of knowing that 0 is the last term there. But in this case, it doesn't even matter. So it's y equals x plus 5. Okay, here's what you do. Okay, don't forget, we can do the domain. We actually could have done a domain right here. Remember, domain is 100% related to vertical asymptotes or holes, but I don't have any holes. So it's negative infinity to 2 and then 2 to infinity. So 2 is an interruption in the graph, so it's an interruption in the domain. Now, this is what you do, everybody. You graph everything. You graph everything. So 0, 0, negative 3, 0. X equals 2. Make asymptotes dotted lines because they're not part of the graph. They control the graph. They're not part of it. And you can even, if you're going to tell me you can't graph y equals x plus 5, there's the door. That's a grade school, plus math 1, plus math 2, and in math 3, graphing lines. At some point, it's got to sink in that that's the y-intercept 5, and then rise 1, run 1, rise 1, run 1, fall 1, run 1. So I got this dotted line. Now, listen. This point and through next week, and hopefully here this makes sense, you should be able to graph without your graphing calculator. The whole point of asymptotes is they control the graph. The graph is controlled by it, dictated by it. The only way this graph could have these two x-intercepts and these asymptotes here is if the graph did this, came down, and then approached that asymptote from there to there. It's the only way that could happen. I mean, I guess you could say it could come down here and then this could approach this, but then what the heck is happening here? It can't, it's not doing this. That's no way. That wouldn't be a function, and it couldn't turn around and come back there. I'm sad that just did that automatically, by the way. There would be another x-intercept. So that's not an option. The only option, get rid of that bad stuff, back, is that, and then the graph comes through and approaches that asymptote. So the next thing is with the parts that I have, what is the only way that this graph could happen? Now, here's what's missing. There's got to be something on the right side. There's always something on the right and the left of vertical asymptotes. There's no graph there. By the way, do you see any x-intercepts here? Did you get any x-intercepts from your equation? No. So where is this graph? Is it below this slant asymptote or is it above? Just flip a coin and say something. 3, 2, 1, go. Above! So here's where it is. It's just off the scale. It's going to be controlled by these asymptotes somewhere way up here. And you're going to want to draw that right now. And then I'm going to prove it. So one thing you can do is actually look at your graphing calculator. Oh, I love a good sneeze. All right, let's go. Clear. I'm going to go ahead and use that cheating thing. Those that have the super fancy calculators, alpha, graph, and then for movie purposes on the next one, I'll use old. Who has an 83? 83 out there that has to use parentheses? Some people don't even have their calculators. All right, anyway, that's great. Great. All right, anyway. Go ahead and I guess, did I tell you to get your calculators out? Did I or no? No. Oh, okay. All right. Sorry, I fell asleep there for a second. Getting old. X squared plus 3x. Getting old. I am old. Okay. Just heard Chewbacca out there. Ruh-roh. I hit graph. Do you see what I see? Did you see what I graphed, though? Yeah. No. All right. We're missing something, right? That's what I'm saying. Correct? Are we missing something? We're missing that other part. Okay, so just hit your window. And what we're missing is, and we should have this knowledge that the graph is somewhere up here. It should be. So what I have to do is go ahead window and extend my Y max. I'm just going to double it. I'm going to make it up to 20 and then get ready to get excited. Okay? So it is up there. So what I was originally going to do was like change. I made this yesterday, printed it, and then at home, I'm like, this is a problem with that denominator. So on a test, we'll probably extend this graph a little bit more to give you a hint of what your scale should be, you know. But we got to know that that part's up there. So it's just that it looks a little different because of our scaling there. Got it? Oh, wait, hold on. Here's another thing. Input, say it. I'm sick of inputting, outputting. Right? I could plug in 3. You could actually plug in points to give a guess. Where is this at? So if I plugged in 3, and this actually infuriates me, anyone that thinks this is hard, it does make me mad. It actually, how could you be in this class and not understand how to take 3 and plug it in for X and evaluate? I've been doing this all year, and some people are looking at me like I'm doing calculus. Can't happen. 3 squared is 9. 3 times 3 is 9. What's 9 plus 9? 18. Hold. That's easy. What's 3 minus 2? So when I plug in 3, this is why I don't see the graph. It's 3 comma 18. So that means it's above this slant asymptote and definitely to the right of the vertical asymptote. That means all of the graph is up there. That's what you can surmise. So without a graphing calculator, you could just input 1 point to figure out where am I at compared to these asymptotes. And wherever that point is, all the rest of the points are, and the graph has to be controlled by those dotted lines. So it does look like that little U that's sliding like that, all right? Just like the calculator showed. So anyway, this is today. Today we're graphing after everything we've done throughout the week. We're making informed decisions. Okay, watch my fingers here, and I do want the screen to show this screen a little bit more. Not that anyone does this, but here we go. Input, say it. 4 comma, 6 comma, 8 comma. Here's my X finger, here's my Y. Where's my Y finger going as I plug in big X's? Infinity. -6 comma, -8 comma. I'll switch the fingers, the right hand is. So where's the Y's going as X's get big? Where's the Y's going? Negative infinity. That's the end behavior. That's the end behavior I just did. I don't understand that. Friday, Monday, Tuesday, Wednesday, Thursday. We talked about that 5 days. Okay? How to find end behavior, these limits. And that's why I wrote these in. I typed them in because I didn't want you to have to write these every single time. And then the quiz that we're going to have Thursday, it's fill in. It's just like this. So giving you some information. All right, now here's the next thing. I really hope, I know I threw this at you yesterday, all right? And it was the beginning of the notes that you didn't even have. You just had to look at it. I threw these in here because vertical asymptote limits, and I made you fill in that blank. Because first, what is the vertical asymptote? I find it. Okay, so I'm going to put a 2 here. But then what happens when I jump just to the left of 2? 1 comma, 1.5 comma. 1.9 comma. Where's my Y finger going as I plug these in? Down to what number? Negative infinity. So if you want this one more time, that said 2 negative. Grab your highlighter, maybe a third one. That means left of 2. Left of 2. Because I just covered that yesterday. So I understand. I know sometimes I seem ununderstanding when I make my comments. I don't understand how people can't factor. I don't understand how we can't do certain things. Input, say it. Yeah, I don't understand that. 2 plus. Hello. Chromebook, hey. You're a big deal out there in the field yesterday. Yeah, I saw you out there. Anyone? Yeah, who is it? Jonathan. There we go. And then right of 2. We had a customer. Right of 2. Okay, sorry. I got distracted. When I jumped to right of 2, 3 comma. Well, that doesn't really say a lot, but I know this graph is going up off into what? What is that graph going off into? Infinity. I never understood. You know what we also could do? we could highlight, although this graph isn't great, we can highlight in green. This is what we're looking at. We're looking at that arrow. That's why it's negative infinity. This one isn't so great, but it does exist. Oh, what color did I make that last one? Salmon? Oh, boy. So it's that arrow. I know that's way up there, though. It's that arrow right there that shows that it's going to positive infinity. The tragedy is this. I have a question on the quiz that we had from old CAT tests with all these limit questions. And the tragedy is someone missing every single one of them. These should all be free points for everybody. All right? We do have to have you fill that in too, like you have to write the 2 minus and the 2 plus. Just giving you a heads up. All right, and I don't want to use highlighters on this. Maybe I'll use like a different color pen on this. Okay, and now we throw these in here. Intervals where f of x is less than 0. If you get the graph, it's just like the polynomials. It's the same analysis. Input, say it, and above or below. What am I looking for, above or below? Below, you're already trained for this. Which graph is below? Well, this one right here. So that's these x's that create that below situation. And then that's these x's that create that, because that's where the outputs are below the y-axis. This is no different than analyzing a polynomial inequality. Once you have the picture, it's done. Okay, so do I use brackets or parentheses? It's a very simple question. Parentheses, there's no equal to sign. And then 0 to 2, but just wait. I'm going to change the second one because the program I'm dealing with doesn't allow me to do underlining, or I couldn't find it. It's actually just Adobe Acrobat, but make that an equal to. So change that. Quick question, go ahead.
Less than 0, would you have to do the negative sign next to the 2?
No, that's just about the limits. That's just locating a limit and where you're jumping. Theoretically, what 2 minus means, are you listening? It's like, it's 2 minus, that's 1.9 is left of that. It's like infinitely plugging in 1.9, 1.99, 1.999, 1.9999 forever. So that's what 2 minus means. Like, as I keep plugging those in infinitely forever, where are the y's going? So that's specific only to evaluating that limit, okay? That type of limit. All right, and then I got to choose another color. I think purple's good. Input, say it. And those outputs are what? Positive. And these outputs are what? Those outputs are what? Positive. So that's maybe that's a good way of doing this interval stuff without highlighting the graph. So I got too much highlighting going on. Now, here's where we got a problem. This is, I made it equal to, so therefore these are brackets, right? 0 to 2. Oh, wrong. What am I doing? Whoa, 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 whoa. What are my x-intercepts? -3, right? -3. So it's bracket -3 because -3 is a 0 and 0 is a 0, which sounds silly probably to many. And then union. Now listen. What is 2? Starts with an A. And then I'm going to cover what you were supposed to look at yesterday. Actually, 7th hour, I did get through it. I actually shoved the notes at him real fast because I was worried about getting cut short in class. Well, that's great. There we go. You were supposed to watch this video. Remember I said watch the last 3 minutes or so, and I think I kept it quick. Filling in this chart. The problem with an asymptote is what happens as its output value. It's undefined, right? It's not an answer. It's a problem. It's a domain issue. Same thing with a hole, which we don't have a hole, but this had a hole yesterday at this position. That's why in this chart we put undefined there. And then this was to help analyze what I'm doing right now. And I knew I was short on the notes, but I did this yesterday, what I'm doing right now, all right, in the video. If you didn't watch it, this is why we struggle. All right, these are the things that are not happening. Oh darn, I forgot to make a video again or change that. Never mind. Just don't worry about what I'm saying. Okay, so the whole point of this is 2 can never be a bracket. 2 is undefined at 2. Or when I plug in 2, I get undefined. That's not solving an inequality. All right, so Asymptotes never have brackets because they can never be part of a solution set. They're undefined there. All right, let's speed this up. Here we go. What's the first thing we do? Starts with an F. Factor. I'll just leave this as. So this is x minus 2, x plus. You know what? I don't want to cross that off, though. I do need the full unfactored equation for analyzing some parts. Okay? So I need it factored for some parts, unfactored for others. So I want to stop canceling there. On the bottom, maybe off to the side, pull out that -2 first because it is a GCF, and then it makes your factoring wrong. What am I doing? What am I doing? Is it Friday? And then +6, isn't it? And then we'll write the full factored version right below. So was that pot fumble, or I don't know what that was? And it's not 1 and 6. -6 plus 1 is -5, but -6 times 1 is -6. If that was -6, then it would be x minus 6, x plus 1. 6 and 5 are sometimes funny to deal with. People make some mistakes on that. All right. Oh, by the way, do we have a hole? We do. So that's why I wanted to do this kind of question. What I did is I used that program, but I got all different types of questions that could happen. Our first one, we had a slant asymptote. That's unique. Our second one, we definitely have a hole. Here's what I'm going to do. The hole is 2 comma. See, the hole is located at that naughty value for x, which is 2 comma. Something else to say. That means x minus 2 on the top does not make an x-intercept, and x minus 2 on the bottom does not make a vertical asymptote. It's a hole. So we got to make that understood as well. All right? And then how do I get 2 comma? You take your remaining function, which is f of x equals x plus 2, but then plug in 2 for x, the naughty value for x. So I'm taking the remaining x plus 2, but then I'm plugging in that 2 in for that. And then down on the bottom, we do have to keep that -2, and then it's 2 minus 3. And then input, I have to get the output. If you're telling me you can't get these outputs, I'm going to cry. 2 minus 3 is -1. -1 times -2 is 2. Hold that 2 in your head, I mean. Hold that value in your head. I'm getting my words. 2 plus 2 is 4. 4 divided by 2 is what? 2 comma 2. Here's what you do about it. 2 comma 2, draw that hole right now. That is an interruption in that graph. Now, we didn't necessarily have to do this first, but since I established I have a hole, I want to get it done. It's the hardest thing of this question. It really is. All right? And then notice what I said about domain. Did I say this before in the video? I don't find that first, even though I have it listed as A. I got to get my issues done first. So I really probably should find A kind of last, but we're going to go ahead and do our highlighting. What's that for? No time. It's x-intercepts. So the x-intercept is -2 comma 0. The y-intercept. Look at my hand. The y-intercept comes from plugging in 0 for x. So 0 minus 4 over 0 minus 12. What's -4 over -12? 1/3. So plugging in 0 for x, I get -4 over -12. And then I guess I'll highlight that. I have yellow, so I'll do green. And that's why I wanted this original. That's what the y-intercept is. Guys, the reason is, I just saw a group last hour, like, how do I find the y-intercept? You plug in 0 for x. 0 squared minus 4 over 0 plus 0 minus 12. It's -4 over -12. All right? Now, you're going to want to make that 0 comma 1/3. I just want you to know where it comes from. Maybe I'll highlight that in green as well. Ruff! I hit that. Okay. Might as well highlight that so you know where it's located in the equation. And then I could grab my third color. This is blue. Now, don't get confused with that -2 on the bottom. That -2 on the bottom is just a shh. You guys don't listen. All right? Pay attention. Okay? So anyway, -2 on the bottom is just a stretch and a flip factor. You'll see that when you get your picture. It's nothing you have to think about. All right. So anyway, vertical asymptote is x equals 3. So I gotta try to keep them focused, you know. And then horizontal asymptote. Let's go peach or salmon. What's the horizontal asymptote? Yeah, that's where I look. What's the horizontal asymptote? -1/2. Good. Last hour, the best person said -2. They did a flipperoo, and most anyone in the first hour, they just give me dirty looks, and I'm not answering your questions. Right? Y equals -1/2. That's the coefficients in front. Okay, now you stop. Hammer time. And graph everything. So -2, 0, 0, 1/3, which is really small. Okay, I kind of have a feeling I know what's going on there just with these 3 points. I bet you they connect with a curve and then something else happens. X equals 3 is right here. And then y equals -1/2 is right here. Okay, I got it. I know what this picture's doing. Numero uno. This is exactly what's happening. I connect these. I don't go through that. That's a hole. The only way that this can continue is if it goes up and is controlled by that asymptote. And the only way this could continue is this goes down and controlled by that asymptote. Why? There's no other x-intercepts. So it hits this x-intercept, and then it's got to stay below and be in that little tight space there. And then after this one, there's not an x-intercept. It's not going to come down and cross this and follow this asymptote down here. It's got to go up there. Here's one more thing. Where is the graph on the right side? Well, let me ask you this. Is there an x-intercept? Just tell me yes or no. No. So where is it, above or below that horizontal asymptote? Below. That is what you are going to be able to do now. The asymptotes control, form, shape the graph, whatever you want to call it. When you get your information, only certain things could happen. All right, and that's the key. I don't get that. Well, all right, fine. Let's go to the graphing calculator. Y equals, I got to slide this over. Of course it won't. Don't do it. Right? It's technology. Some goofball thought that'd be a great thing to have that happen, and it's only caused me pain and heartache and suffering. Is everyone okay? Technology people. Let's do an upgrade, downgrade. All right, let's talk about the TI-83s. All right, so I would need this. I would need to do x squared minus 4. Always type the original, not your factored version. Then divided by denominator. -2, a lot of talking out there. Hopefully it's math. X squared plus 10x minus 12, and then close it. This is the old school numerator over denominator if you have an older calculator. Window, wrong. Zoom, standard. Boom, shakalaka. Okay? So that's the graph I see. Oh, I don't see that hole. You know what I could do? I could do this. Second table. Did I show you this? How to do the plug in the table in there? And I plugged it in. 2 comma, but I'll delete. And then 2. What does 2 give me when I input that? Error. So 2 comma is an error. That means there is a hole. I will bore you with a story. One time, I think I did it by myself, but there's a way of zooming in on a graph, and I hit zoom in about 10 times in that spot, and then I finally found that the graph was disconnected there. You could see like the open space. They don't want to see me do that? No. All right? So that is actually something I've done in the past. It was a different calculator. It may not have been this one, but okay, here we go. Input, say it. Now this is Monday, Tuesday, maybe even Friday last week, Wednesday, Thursday. End behavior limits. As x goes to -infinity, where's y going? What kind of 1/2? Negative. As x goes to +infinity, where's y going? -1/2. The horizontal asymptotes dictate these limits. Actually, the slant ones do too, but that's infinity and negative infinity. All right. So end behavior limits, that's that. And then I only have this, which is 3, and I'm not over explaining this. 3 negative. What happens when I'm left of 3? Guys, all you have to do is this. X finger, Y finger. Where's my Y finger? Where's that going? Infinity. I don't understand how anybody misses these. I really don't. And then 3 plus. 3 plus. X finger is on the right side of 3. Where's my Y finger? Where is it? Down. I don't understand how anybody misses these. It actually makes me really, 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 really sad. All right? Okay. Okay. Intervals where we're below. Not going to over explain this. Maybe not do this, maybe in colors, but it's really going to jack up this graph. You have to understand that this graph is all below. So below is from negative infinity to that negative 2x intercept there. Okay, so that's tough. You got to know that that went underneath. And then on the right, it's actually easy. Union that with 3 to infinity because all of that is below. All of it. Okay, so that's how you solve an inequality absolute or rational function. Words in my head. And then above, I think I used purple. This is all above, but we have an interruption. We have an interruption in that part of the graph. So above, and then let's put an equal to on this again. So we can use a what? Bracket. You got it. That was fast. That's what I like. That means someone's paying attention, not licking the walls. All right, and then it's at 2 that I had an interruption there. So then I got to go 2 to 3, and 3, bracket or parenthesis on 3? Bracket or parenthesis? It's a parenthesis. Got that same person focused. Answering that question out loud. Love it. Okay, never a bracket on an asymptote. And maybe the last one, I won't answer that. I don't want to talk this whole period. What I tried to do is get 3 different cases going on. All right, and then I'm going to move myself over here again. Again, I just like, sometimes I point at the board too. That's not moving now. Technology. All right, I take out a 2, and that's x squared minus 9. X squared minus 9 is a difference of 2 squares. I'm tired of teaching factoring like you've never seen it before. Tired of it. Are there any holes? Are there any holes? No holes. So let's alleviate our thought process on holes. All right, let's get rid of it. You're gone. All right, and then we could just do x-intercepts. By the way, the x-intercept is the 0 of the numerator. Holes are, yep, when you cancel. Good, I hear a good group over there. Cancel factors, nothing cancels. All right, and then let's do y-intercept. What's the y-intercept? It's on the page already. No, it's on the page already. What's the y-intercept? If 0, 0 is an x-intercept, 0, 0 is the y-intercept. I mean, it's the same. Look, graph it. It intercepts both. Come on. All right? But if I did plug in 0, okay, fine. If I plugged in 0 for y, it'd be 0, comma, 0 over negative 18. That's what the output would be. Okay, not error. Wrong. 0 over negative 18 is 0. I don't know if you were talking about something else over there with that group. All right, but that's okay. Didn't mean to get up in your grill there. All right, and then that's that. That's where we got this from. Okay, that's how you find a y-intercept. Anyway, vertical asymptotes, you got 2. X equals 3, x equals negative 3. It's the zeros of the denominator. If you want to get a highlighter out one more time, that's it. The 2 is useless. The 2 is just a shrink factor. It makes the graph condensed a little bit. You don't even have to worry about that. And then what's our horizontal asymptote? That's where we look. That's where we look for horizontal asymptote. What do we got? What do we got? Y equals what? Oh, we got so many different answers out there, and it makes me want to hit my head up against a wall. That was Monday, Tuesday, Wednesday, Thursday. We're now on Friday. 4 days in a row of talking about horizontal asymptote rules. When the numerators is smaller, the degree is smaller than the denominator, it comes to 0. Okay? Now we want to draw all these. So y equals 0 is the last thing that I found. X equals 3 and negative 3. We want to draw those. Are you okay over there? I hear a bunch of laughing. I don't know. I didn't know asymptotes were so funny. Teaching in America. Okay, now I don't have a lot of information. I don't see anything. I don't even know what's going on in the middle. But I know what's got to happen. There's only one x-intercept, and I have these asymptotes. Don't draw this. I know it's got to be at least either this or this. And I'm going to hit the back button. Not both. Not both. Input, say it. I could input, and don't tell me you can't. All I need to know is, where am I at in each little sector? Am I above or below? This is all you have to do. So maybe a smart one would be 1. 1, hold that in your head. 1 squared times 2 is 2. What's 2 minus 18? What kind of number is that? Negative. What's 1 over a negative number? Negative. So I know I'm below, so I know everything. I know exactly what's happening. I'm going to prove it through input, output. I know this has to be the case. 1 input, output told me exactly what's happening, including what type of asymptotes I have. I don't trust you, Mr. S. Good. Go to the other side then. -1. -1 up on the top. -1 squared, though, is 1 again. 2 times 1 is 2. What kind of number is 2 minus 18? Negative. But it's negative over negative, which is what? Positive. That's why I know I'm above here. And that's all I needed to know that this is what's happening. Now, what I don't know what's happening off to the left, again, I can see people are looking around and, okay? Look up here. This is important. This is it. Okay? -4. -4. Hold. What's -4 squared? 16 times 2, isn't that larger than 18? So what do you have in the bottom, a positive or a negative? But what's a negative over a positive? This is what I know. I know this resulted in a negative. That means I know this graph is below and controlled by these asymptotes. Because this is what happens. This is the point of the asymptotes. So I bet you I know what's going to be here. What do you think it's going to be, above or below? It's going to be above. Because it usually does alternate, but maybe not. Let's check. 4 over, well, there we go. 4 squared, 16. 2 times 16 again, positive. What's positive over positive, though? Positive. So I got a positive on this one, so that means I got to be like this. I don't trust you, Mr. S. Fine. Yoink. I'm going to go back to old school. Y equals, clear. No, I'm going to go to new school. Our little fancy fraction button there. And always type in the original, not the factor. Just do the original when you are typing this in the calculator. Graph. There it is. Ah. Okay. I got exactly what the calculator did, so I must be right, because technology rules our lives. All right. That's a good end. Let's go.